So we've got one more trig function to do the graph for, and that's cotangent. Okay, so we'll start with the way we've been doing it. Cotangent of x, and then we're going to have 0, and then we'll do pi over 6, pi over 4, pi over 3. The next quadrantal angle, pi over 2, and then we'll just do some quadrantal angles, pi, 3 pi over 2, and then 2 pi. Now remember, the period for cotangent is pi. Okay, so think about when you put in, I'll draw the diagram like we have been doing. When we think about, y over x, so at 0 degrees, y over x would be 0. No, something's wrong there. Nothing's wrong. I just I just spaced it. Okay, so for cotangent, it's going to be x over y, right? Okay, so that's going to be undefined because 1 over 0 is going to be undefined. So we're going to have an asymptote there. All right, and then if we go to the next quadrantal angle, pi over 2, then you're talking about the point 0, 1. And so that's going to be x over y, so that's going to be 0. Oops, put it in the right place. So we can have 0, that's fine. And then what happens at pi? Well, you're at negative 1, 0. And so when you go x over y, that's going to be undefined. So you're going to have an asymptote. And then when we're down here at 0, negative 1, then you're going to get 0. And that's okay, 0. And then at 2 pi, you're back to 0, so it's undefined, and another asymptote. Okay, so now we know where the asymptotes are. Let's mark off 2 pi, and then halfway in the middle, pi, and then pi over 2, 3 pi over 2. And then where are these asymptotes at? They're at 0, pi over 2, I kind of made this skinny. And then, let's see. No, not pi over 2. I don't know what I was thinking there. Pi. Oops. Must be late in the day. Pi. And then 2 pi. Okay, so now we've got the asymptotes. And you could keep going further. We've actually gone 2 periods here because the period is pi. Okay. Now we can put the zeros in. There's one at pi over 2, and there's one at 3 pi over 2. Okay, so now let's think about where are pi over 4, so pi over 4, and then pi over 6 a little before, and pi over 3 a little after. So pi over 6, that's going to be this, you can look that up on your unit circle, but that's going to be the square root of 3. Now, the square root of 3, is it 1.7? Let me check real quick. Square root of 3. Yeah, it's like 1.7. And then pi over 4, well, that's going to be 1. And then pi over 3, that's going to be the square root of 3 over 3. So let me divide this by 3 in my calculator, and I get 0.6. Okay, so we can graph those. So here's 1. Let's mark a 1 off. And negative 1. Okay, so square root of 3 is like 1.7. So up here. And then you're at 1. And then you're at 0.6. And it's really skinny because I didn't draw it very big, but whoops, not what I want to draw. Not what I want to draw. Let me get that out of there. Then you're at 0. I forgot about my 0 that I just erased. Okay. And then we're at 0 right here. Okay. Now when you go to the next quadrant, I'll have it drawn in. We could put it over here if you wanted to. So if I'm I did the first quadrant with the special angles. Now if I go to the second quadrant, what's going to happen with cotangent? Well, they're all going to be negative, right? So you're going to have 4 pi over 3, which is going to be negative, I'll just go down here, negative 0.6. And it's probably helpful to see the square root of 3 over 3, but it's negative. And then you're going to be at 3 pi over 4, oops, 4, and that's going to be negative 1. And then you're going to be at 5 pi over 6. You know what? That's not a 4 there, is it? It's a 2. Ah, 2. And 5 pi over 6 is going to be the square root of 3, and it's going to be negative, and then that's going to be negative 1.7. So what happens then when we graph these, they're going to come down here, so you're going to have like, you know, halfway in between, and then a little before and a little after. You're going to have negative 0.6, then you're going to be at negative 1, and then you're going to be at negative 1.7. So it's going like this. It should look like the tangent curve, except it's going the other direction. Tangent went this way, but cotangent's going the other way. And then the same thing's going to happen in the next period. These are periodic functions, so it's going to repeat between pi and 2 pi. Okay? And you keep going if you want, draw more asymptotes and draw more cotangent curves. So the big thing you want to remember is where the asymptotes are. And the asymptotes start at 0. Okay? 0, pi, 2 pi. All right. So when we have y equals a tangent bx, then we get a stretch factor of the absolute value of a. We can still have that, and maybe it reflects. The period is going to be pi over the absolute value of b. And then what's the domain going to be? Well, you can see that you're getting an asymptote at every integer of pi. 0, pi, 2 pi, 3 pi, 4 pi, like that, right? So it's all real numbers. But x cannot equal pi over, and then we're going to go b, k, and k is an integer. Okay? So we have b in there to account for if the period changes, and then every, you know, integer unit of that is going pi over b. That would be an asymptote. The range is going to just be all real numbers, negative infinity to infinity. So you can see that from this curve. It's just going all the way up and all the way down. There aren't any breaks in it that way. The asymptotes are at x equals pi over the absolute value of b, k, where k is an integer. Symmetry, cotangent is an odd function, so it's symmetric about the origin. All right, and that sums up the cotangent.